Okay, so let's begin chapter 1, complex numbers, year 1 or year 12 AS book from Core Pure Mathematics, so you're further mathematicians. Okay, so to begin with, we're going to look at the idea of complex numbers, understanding and using the definitions of complex numbers, imaginary numbers, imaginary and real parts, how to add, subtract, multiply by a number or divide by a number, multiply or divide complex numbers. We're going to look at various aspects of complex geometry as well. Okay, so the idea of complex numbers came about from trying to solve quadratic equations that, as you know, sometimes do not have real solutions. So in the situation when the discriminant of a quadratic equation is negative, so that's that bit under the square root in the formula. So you remember the solution to this equation is x equals to minus b plus or minus square root of b squared minus 4ac over 2a. So this bit here that we are square rooting, it's called the discriminant. If the discriminant is positive, then you have two real distinct, meaning not the same, roots. If it's equal to 0, then you have one repeated root. Okay, so I'm saying repeated. If you were to factorize that quadratic, you would have two of the same solutions from both brackets. And finally, if you've got 4b squared minus 4ac being less than 0, then you have no real solutions. Now, real meaning solutions belonging to the set of real values. So these are all the numbers that you've ever had to deal with. They belong to real numbers. So on your number line, you might consider, remember when you were little and you started to count, those counting numbers starting from 1, 2, 3, 4. These are natural numbers. So you would write them like that, and natural numbers have 1, 2, 3, so you're counting numbers. Now if you start including 0 and -1, -2, so all your integers, they belong to a set of whole numbers. Notation is z with a notice like a double line in the middle. So these are all your integers. So you could have minus, let's just start from some value there, -3, -1, 0, 1, 2, etc., etc. Okay, you also talked about rational and irrational numbers. So your the ones that can be expressed as fraction are your rational numbers, and the ones that cannot be expressed as fractions, they are irrational numbers. So like pi, you will find out about the special number e. These are your irrational numbers, but they are all real values. They are all there on the number line. So like pi is somewhere here, half will be here, so rational, irrational number. E will be somewhere here. Okay, your thirds, they are irrational numbers as well. So like square root of 2 will be somewhere here. So you could actually fill the whole of this number line and account for all real values. Now, what happens for some mathematicians centuries ago, they decided that what would happen if you actually could solve an equation that has got the discriminant less than 0. Okay, so for example, the equation, a very simplistic equation, x squared plus 4 equals to 0. So they knew that x squared can never be equal to a negative number. You can't have a solution to this because you cannot square root negative number. But they decided, what if you could? Why can't this be a solution to this equation? And then they came up with this idea of rewriting square root of -1 as I. So if you have square root of -4, that would become square root of 4 times square root of -1. So it would be plus or minus 2i. So from then on, it became possible to find solutions to quadratic equations with no real solutions. Okay, so in fact, this part here only accounts for one part of a complex number. A complex number can be written in the following form. It will have the real part, which we'll call RE, and imaginary part. So A is real part and imaginary part. So equal IM of that complex number is B. It's the coefficient of I. Now, to begin with, we're going to just see how we can add, subtract, simplify some expressions involving square roots of negative numbers, and multiply or divide by constant. Okay, so in the example 1, what would -36 be? I want you to be really quick with this. -36, you square root 36, which is 6, and square root of -1. You don't need to write it, but I will for this, so we get used to it, which is 6i. Okay, this one here, you can split it into root 28 times root of -1. So this one, your traditional thirds work, so it's 4 times 7, so it's 2 root 7 multiplied by I. Now, you can put the answer like this, as long as you keep the I further away from the third, from the square root. Might be better to stick it in between 2 and root 7. Otherwise, you might accidentally put it under the square root, and then the meaning is different of that. Okay, so let's have a look at how you can add. It's really very intuitive. If you've got two complex numbers, 2 plus 5i, and then you add 7 plus 3i, the second complex number, you need to add the real parts together and then imaginary parts together. So you're going to obtain 9 plus 8i. Here exactly the same, except we are taking away. So we are going to subtract the real parts. 2 take away 5, so it's -3, and subtract the imaginary parts. So -5 take away -11 is -5 add 11, so that's going to be add 6i. Okay, here, just like multiplying out brackets, it's really not difficult. So we've got 10 times is 10 minus 16i, and here again the same, half the 10 to get 5 and half 6i to get 3i. Okay, so you can have a go at exercise 1a when you're ready. Okay, we're going to, I've actually shown you how to solve one of the equations before as I was introducing it. So this one is going to be more interesting. But let's do z squared plus 9 equal to 0. So let's move 9 across. So remember, quadratic, square root plus or minus square root of minus 9. That is going to be 9 times minus 1. So it's 3i. So it's plus or minus 3i. Okay, in this instance, we are going to complete the square. So z plus 3 squared minus 9 plus 25 is equal to 0. So z plus 3 squared is equal to negative 16. And then we've done this type of question before. We are going to square root it. So it's plus or minus square root of minus 16. And I want you to write it automatically. Square root of 16 is 4. Square root of minus 1 is I. So z is equal to minus 3 plus or minus 4i. So that is 2 roots. Okay, so practice questions from exercise 1b before moving on to the next section. Multiplying two complex numbers is very, very simple as well, very intuitive. You just need to remember that if square root of minus 1 is equal to I, then I squared must be equal to minus 1. It's worth remembering the two guises of this identity. Let's multiply it out. So you get 2 times 4, which is 8, 2 times 5, which is 10i, 3i times 4, which is 12i, and then you've got 3 times 5i squared, which is 15i squared. We're going to gather the real parts. So the real part is 8, but it's also this one number as well. So it's 8, 15 times minus 1, minus 15. And then imaginary parts are going to be 10i plus 12i. So it's going to be minus 7 plus 22i. Part B, just expand 2 brackets. So either write it as 2 brackets, or you should know how to do it quickly. It's always going to be the first term squared. Then you're going to have minus 2 lots of the first and the second term plus the last term squared. So you're going to get 7 squared minus because there's a minus between the two terms in the brackets. So the product of the two things in the brackets plus 4i all squared. So it's 49 minus 8 times 7 is 56i, and then plus 16i squared. The real parts are going to be 49 and 16i squared, because that will go to minus 16, and then minus 56i. So that's going to be 49 minus 16 is going to be 33 minus 56i. Okay, so then we've got one more example, because before we go on to exercise 1c, very, very good idea to have a practice those, as you know, cubing or raising to the power 4 of I. So if I squared is equal to minus 1, then I cubed is simply I squared times I. So that gives me minus 1 times I which is minus I. Okay, similarly here, you can split it into, you can actually multiply the I cubed by I, which gives me minus I times I, minus I squared, which is minus 1, which is 1. Or alternatively, you could split it into I squared times I squared, which gives me minus 1 times minus 1, the same answer. Here, we've got to write it as 32 I to the power of 5. So 32, I like to split it into the second method, I squared times I squared times I. Each time I've got I squared, that accounts for minus 1 times minus 1 times I. Minus 1 times minus 1 leaves you with 1, so it's 32I. Okay, so now you're ready to move on to exercise 1C and practice questions on multiplying complex numbers.